Okay, returning to lesson 20, section 7.2, law of cosines. The next thing we're going to talk about is the area of a triangle. Okay. Now, in all these situations, we actually refer to the area of a triangle as the value of k because we don't want to confuse A, the area, with A, the angle at the angle A. Okay. So, when we're talking about this, all of these angles, okay, there's a way to talk about the area of them, specifically in reference to these, this one, and this one, formulas, okay? So, the area K of a triangle ABC is 1/2 the product of the lengths of any two sides and the sine of the included angle. So what that means is if I'm given, and I'm going to go ahead and bring this paper back from last video, if I'm given an angle and the two sides, okay, that are adjacent to it, then I can find the actual overall area of this triangle. Now there is a proof for this, okay, but we're not going to actually work through that proof. We're legitimately just going to remember this formula and apply it, okay? So, for number 7a, it says find the area of the triangle given the following information. I have A is 62 degrees, I have B is 12, and I have C is 5.0. I'm going to go ahead and put that in there meters. Okay, so how do I find the area of this triangle? Well, the area, again, corresponds to, I'm going to go ahead and write this out. If I put the A here, little a is here, I'm going to put the big here and big C here. That means that this is B and C. I have this piece, and this piece. I have the two sides and the included angle. I can utilize the formula up here. Okay, so my area K is going to be equal to 1/2 B, 12, times C, 5, times the sine of the angle I'm given. 62 degrees. Okay. And how do I evaluate what this is going to be? Well, simply I type it into my calculator, 0.5 or 1/2 times the 12 times the 5 times the sine of 62. Make sure you either type in a degree symbol. Again, make sure you type in the degree symbol here. Or you make sure that your mode is in degrees. I'm going to go ahead and hit enter. And it gives me 26.4884. What do I round this to? Well, the area of something, okay, is always a squared unit. So this is obviously going to be in terms of meters squared, okay? And how accurate can I be? Well, if it doesn't tell me, let's round to, again, the decimal places that I'm given in terms of the meters. So K is going to be approximately equal to 26.5 meters squared, okay? And that's all I'm looking for these problems. Okay, let's go ahead and look at the next one. Okay, now the next one, it says find the area. This is 7b. Okay, it says find the area such that I'm given A equals 32 degrees, C is equal to 77 degrees, and little a is 14 inches. Well, if I draw the triangle here, I'm given A, let's see, B, and C. I have little a over here, little c over here, and little b over here. They gave me this. Okay, I have that piece. And I have these two pieces. How do I find the area of this? Well, in terms of finding the area for this particular thing, okay, I either have to find this, and this, so I can utilize this, or these two and find this one. Okay, so what I'm going to say is, what is the easiest thing out of all these possibilities to find? I might as well find this one right here. If I find this one, then I can use these three pieces, the two sides and the included angle, in terms of the formula, okay, the area of a triangle formula. So how do I find this? Well, I could try and use law of sines, yes. Okay, A across from A, I can use law of sines, I can find that, wait, for me to use law of sines, I'd have to know what this angle is. Oh wait, I have two angles, I can find the third. I might as well go ahead and start solving pieces of information. So, my B angle is going to be these two added together and 180 minus that. So it's going to be 180 degrees minus, this is 109 it looks like. So that's going to be equal to, it looks like a 71 degrees. Okay. So I know what this angle is now. Now all I got to do is find the side. And I can use law of sines to do that. So law of sines says I'm going to have the 14 divided by the sine of 32 degrees is equal to b, the value that I'm looking for, over the sine of 71 degrees. Now notice with this, nothing here has been approximated. This is exactly 71 because I have these two angles, and every triangle has 180 degrees. Okay, so what's going to happen is I'm going to find an approximated b. And yes, I'm going to have to use that approximated b to evaluate the area. Okay, so my approximation of the area will actually be a little bit problematic. It's not going to be as accurate as we'd like it to be. So what we're going to do here is we're going to solve this thing for b. b is going to be equal to 14 sine of 71 degrees divided by the sine of 32 degrees. I'm going to type this into my calculator. I'm going to round the number of decimal places I'm given over here, which is 0. Now, I shouldn't actually round this yet. I shouldn't round this at all. Let's go ahead and first see what I'm going to get in my calculator. Sine of 71 degrees divided by the sine of 32 degrees. Okay, and I'm going to go ahead and show this to you here. 14 times sine of 71 divided by sine of 32 gives me approximately 24.979767, and so on and so forth. So it looks like it's close to 25 inches. Okay, again, rounding it to 25 will actually give us a lot of problems. So what I'm going to do instead is this. Okay, in my calculator, so I don't have to make any issues with this. Okay, I know, I'm going to move this off to the side for a moment. I know that this value right here is the exact value for b. I know for me to get the area of this triangle, I need to use 1/2 a times b times the sine of the included angle c. Okay, this is equal to 1/2, my a value being 14. Okay, my a value being 14 inches. My b value being this thing down here, so I'm going to have 14 sine of 71 degrees divided by the sine of 32 degrees. The sine of c, c being 77, so times the sine of 77 degrees. Typing this into my calculator will give me a more accurate value for the area. So what I'm going to do is I'm going to take what I had plugged in, this thing right here. Okay, and I'm going to go ahead and start typing things in. I have a 0.5. Okay, I can't see my paper and this at the same time. Times the 14 times this thing here, and then times the sine of 77 degrees. I'm going to hit enter in my calculator, and you're going to notice that I have the 0.5 times the 14, the 0.5 times the 14, times this obnoxious looking thing, there's our obnoxious looking thing, times the sine of 77 degrees. Okay, and the sine of 77 degrees is the last piece. This is approximately equal to 170.37676 ... What value is this really? Well, I'm going to round it to, it looks like my values in length is rounded to the whole number, so I'm going to round these to the whole number, so it's 170.37, so 170 squared inches. Okay, and that completes problem 7b. We are going to go ahead and keep on moving. The last formula that we have is Heron's formula. Okay, as I knock the video camera over. Heron's formula says if A, B, and C are lengths of the sides of a triangle, then the area K of a triangle, again, we're using K for the area, is equal to this. Okay, the square root of S times S minus A times S minus B times S minus C, where S is what? S is the almost average of all three sides added together. It's not an average because it's 1/2 times those as opposed to 1/3. Okay, so this is what I use to get a good accurate reading when I have all the lengths. I have all the lengths of the triangle, but none of the angle measures. Okay, so let's go ahead and work through this 9A example. Okay, they gave me A is 7, B is 15, and C is 12. Okay. I want to find the area. The area is supposed to be the square root of s minus a, s minus b, and s minus c. Again, there is a proof for this. We're not going to work through the proof. Okay, let's just make sure we understand how to use the formula we're given. Okay, this isn't going to come up very much often after this. Okay, s is equal to 1/2 a plus b plus c. So what I'm going to do is I'm going to go ahead and plug in a, b, and c. I know what these a's, b, and c value is. I'm going to plug it into here. Okay, let me zoom this out a little bit so you can see it all at once. Okay, so s is equal to 1/2 times 7 plus 15 plus 12. Okay, that's going to be the same thing as this is 22, this is 34, so 34 divided by 2, which is really a 17. Okay, so that's my s value. S value is 17. And I'm going to plug that into this formula up here with the a, b's, and c's. So this is equal to the square root of 17 times 17 minus a, so minus 7. Okay, let me extend this. Times 17 s minus b, minus 15. Times 17 minus c, minus the 12. Okay, so that gives me all this information. I have the square root of 17 times 10 times 2 times 5, and therefore whatever this value is my final solution. You'll actually notice that this right here is 10 times 10, so this is really just 10 square roots of 17. If they ask me to approximate that, I'm going to have 10, the square root of 17, typed into my calculator, and it's approximately 41. Okay, now you'll notice in the original problem they gave me 7.0 meters, so I'm going to round this to one decimal place of approximately 41.2 meters squared. Again, because it's an area, it's a square meter. That actually finishes lesson 20.